Done. Four statements are given as four options regarding bipartite graph, and we have to identify the correct statement. Option is states that bipartite graph is always connected. This is wrong. Why? Because we can give example which is not connected for bipartite graph. We can take this as bipartite graph which is not connected. Here vertex, this vertex is isolated vertex. So option A is wrong. Option B states that chromatic number for bipartite graph is less than 2. This is also false. Chromatic number for bipartite graph is equal to 2. So this is also wrong. And if we see option C, it states that independence number is greater than or equal to V by 2. Independence number is nothing but number of edges in a maximum line independent set. So here option C is correct. Why? Because for any bipartite graph with V vertices, one side will have at least V by 2 vertices. So here option C is correct. Question: a relation R with FD sets is given, and we have to find the highest normal form achieved by the given relation. In order to solve this problem, first of all we need to find the key for the given relation. So here the given attributes are given FDs are A gives BCD, BC determines AD, and D determines B. So here keys would be A. One key would be A. Why? Because if we find closure of A, we can derive all the attributes. So from this FD, A determines A, B, C, D. So here A determines all the attributes of the table. So we can say A is one of the keys, and BC is also one of the keys. Why? Because if we find closure of BC, we can get all the attributes. So here BC is also another key. If BC is key, we can, if BC is the key, CD is also key. Why? Because here B is determined by D. So here in this key, in place of B, we can write D. So here CD will also become key. So here the keys are A, B, C and CD. So here key attributes are all the attributes of the given table. So here we can say there will not be any, if all the attributes of the table are key attributes, then there will not be any partial dependencies and transitive dependencies. So we can say the table will be in 3NF. We have to check if the table is in BCNF or not. So here in order for the table, if the table has to be in BCNF, all the LHS parts of the FDs should be candidate keys. So here A is a candidate key. So there is no problem with this FD. And BC. So here BC is also one of the candidate keys. So there will not be any problem with this FD also. So if we see the third FD, D gives B. Here D is not a candidate key. So this FD will violate BCNF condition. So here the table will be in 3NF. So here correct option is option C. In this question, three tables, parts, supplier and SP, supplier part, are given, and we have to find the SQL query which displays all the part names having more than one supplier. And for the table parts, P number is the primary key, and for the table supplier, SID is the primary key, and for table SP, combination of SID and P number is the primary key. Here the query is all the part names having more than one supplier. If we do cross product of this table twice by taking twice. For example, SPA and SPB. This table is renamed as A and this table is renamed as B. So here SID, P number and quantity. Here also same, SID, P number and quantity. We have to find the part name. First of all, let us find the part number which is having more than one supplier. So if we do cross product of these two tables, we'll be getting like this ID should be same. This part number should be same, and this SID should be different. Why? Because that particular part should have more than one supplier. So here A dot P number must be equal to B dot, here SP table is renamed as A. So here it is renamed as B. So A dot P number must be equal to B dot P number, and this SID and this SID should be different. Why? Because here the part should have more than one supplier. That supplier should not be same. So here A dot SID is not equal to B dot SID. Here we will be getting all the part names, just all the part names. Sorry, here we will be getting all the part numbers, but we want part names. So again we have to do cross product with table parts. So here we will be having P number and P name. So by combining these two tables, we will be getting, with these conditions, we will be getting all the part numbers having more than one supplier, but we want part names, so we have to combine with this table. So here P dot, this is renamed as P. Let us rename this as P. So here P dot P number must be equal to A dot P number. So here, after satisfying this condition, it should also satisfy P dot P number is equal to A dot P number. Then we will be getting all the part names. So here again we have to select, we want part names. So here we have to select part name, and that part name should be distinct. So here select distinct. Here table P is renamed as, table parts is renamed as P. So P dot P name. So P dot P name. So here select distinct P name from where we are combining three tables: parts P, SPA and SPB. So parts SP. These parts is renamed as P. This is first one is renamed as A and second one is renamed as B. So select distinct P dot P name from three tables: parts P, SPA, parts P, SPA and SPB, where A dot P number must be equal to B dot P number, and A dot SID should not be equal to B dot SID, and P dot P number must be equal to A dot P number. So here correct option is option B.